Good morning, students. This is Dr.J.Jaya, Udhaya, Associate Professor in EC Department, RMD Engineering College. So in this video, we are going to discuss a polar plot. So this topic comes under unit number 3. So now we will discuss a problem. Plot the polar plot for the following transfer function. G of s is equal to 15 divided by 1 plus s into s plus 3 into s plus 6. Find gain margin and phase margin. So first of all, we must know what is the another name of polar plot. The polar plot is also known as the Nyquist plot. Using the polar graph sheet only, we can construct the polar plot. The next important thing, the polar plot consists of two parts. One is concentric circle, next one is radial lines. The concentric circles are used to represent the magnitude value. Radial lines are used to represent the phase angle value. So that is very important. Okay. So now they given G of s is equal to 15 divided by 1 plus s into s plus 3 into s plus 6. First, what we have to do now? First, wherever we are having s term, so that s you have to replace by j omega. So therefore, this G of s is equal to G of j omega. We are replacing s is equal to j omega. So therefore, G of j omega is equal to 15 divided by 1 plus, instead of s, we are putting j omega. Okay. Then next j omega plus 3. Next j omega plus 6. Okay. Then next you must know, suppose if you are having a plus jb, then I will find out your magnitude value square root of a square plus b square. Suppose if you want to find out the phase angle value, this is very simple. Tan inverse of b by a. That is imaginary part divided by real part. Okay. So in that way only we are calculating the magnitude value and phase angle value. So here also we are going to find out the magnitude value for G of j omega. So therefore 15 is the numerator value. So 15 divided by square root of real part is 1, imaginary part is omega. So therefore a square plus b square, 1 square becomes 1 plus b square value is omega square. Similarly for this, real part value is 3, imaginary part is j omega, correct? So therefore 3 square 9, so 9 plus omega square. The next 6 plus j omega, 6 square is 36, so 36 plus omega square. So this is your magnitude value. Okay. The next we have to find out the phase angle. So for phase angle 15, that is a constant value, you have to keep it as it is. Then already I told you how to find out the phase angle. So phase angle is equal to tan inverse of b by a. That is imaginary part value divided by real part value. Okay. So here you see 1 plus j omega. So therefore here b value is omega, a value is 1. So therefore we can write tan inverse of omega by 1. Similarly here tan inverse of omega divided by 3. Here tan inverse of omega divided by 6. So that value only I wrote here. Tan inverse of omega by 1 plus, here you have to write it in the additive form only. Okay. Plus tan inverse of omega by 3 plus tan inverse of omega by 6. So this is in the denominator. Next I am bringing in the numerator. So that's why I am getting minus tan inverse of omega minus tan inverse of omega by 3 minus tan inverse of omega by 6. Then after calculating the magnitude value and phase angle value, we have to plot the polar plot. So for that, what we are going to take now? We are going to take a different values of omega. In order to plot a polar plot, we must have some data, some values. Then only it is easy to plot the polar plot. So for that, we are considering a different values of omega. So this is a random value only I am taken. Here there is no rules. You have to select this is a minimum value, that is a maximum value. That is our choice. We can select any values. So therefore, I am selected omega is equal to 0.5, 1, 2, 4, 6, 8 and 10. For this different values of omega, I am going to calculate my magnitude value and phase angle value. Already we know the formula, magnitude value is, this is your magnitude value. So here you have to substitute omega. In this place, omega is equal to 0.5 or 1, 2, 4, 6. Like that you have to substitute. Then you have to find out your magnitude. So if you are directly, if you are doing one by one, it will take more time. So first you have to form a equation. Then you have to consider omega is equal to some constant value. Form a equation. Then after that you substitute your omega, different values of omega. Then easily we can find out the magnitude value. Only for a time consuming, I'm telling this. First form a equation. After that you substitute different values of omega. Easily you can calculate your magnitude value. Okay. So therefore, for omega is equal to 0.5, I'm getting the value as 0.732. Omega is equal to 1, magnitude value is 0.551. Omega is equal to 2, I'm getting the magnitude value as 0.294. Omega is equal to 4, I'm getting the value as 0.100. Omega is equal to 6, magnitude value is 0.043. Omega is equal to 8, magnitude value is 0.021. Omega is equal to 10, magnitude value is 0.012. Similarly, for a different values of omega, I'm calculated the phase angle. For 0.5, I'm getting the phase angle value is minus 40.79. Omega is equal to 1, phase angle value is minus 72.89. Omega is equal to 2, phase angle value is minus 115.55. Omega is equal to 4, phase angle value is minus 162.78. Omega is equal to 6, phase angle value is minus 188.97. Omega is equal to 8, phase angle value is minus 205.44. Omega is equal to 10, phase angle value is minus 216.6. So we are calculated a magnitude value, phase angle value for different omegas. So using this data, we can construct the polar plot. So this is your polar plot. So here they given degrees, 0 degree, 10 degree, 20 degree, 30, 40, like that. So here all the values we are getting negative value. So therefore I am selected a clockwise direction. Now you see this is 0, this is minus 10, minus 20. They will represent only 20, 10, 30, 40, 50, 60, like that only. But we require only negative value. So that's why in front of 10, 20, I am put at a negative polarity, negative. So minus 10, minus 20, minus 30, minus 40, like that I mark. The next important thing here, the magnitude value is very less value only. The starting value is 0.732. The ending value is 0.012. So based on my omega value and the magnitude value, I marked this point is 0.01, then this point is 0.1, then this point is 1. So now you see, so in this polar plot, you will have the concentric circles. So therefore, the concentric circles are used to represent your magnitude value. Then this radial lines are used to represent your phase angle value. Okay. So therefore, for omega is equal to 0.5, already you know the value. Magnitude value is 0.732. The angle value is minus 40.79. So that value only I marked. Here you see, this is 40. So therefore 41, nearly 41 I marked. The magnitude value is 0.732. So 0.7 in between 0.1 and 1. So you're having your magnitude value. So therefore 0.732, then for nearly 41 degrees, I marked here. Similarly, how to mark the remaining points. Then next, after marking all the points, you have to connect all the points using only the freehand. Okay, don't use any scale. Just you join all the points. So once if you join, then you will get the plot like this. So next important thing, so you take your g of s. So g of s is equal to 15 divided by 1 plus s into s plus 3 into s plus 6. Now from this we can tell what is a type, what is the order. So here the type value is 0, order is 3. So already you know that where you have to start your polar plot, then where you have to end. So polar plot, you have to start with the type 0, type 1, type 2, type 3. It does end with order 1, order 2, order 3, order 4. So therefore this is a type 0. So therefore it starts in this quadrant. So it starts in this quadrant. Then what is the end? Order 3. Type 0. So this is type 0. Then it will end at the order 3. Okay. Then next, how to find out the magnitude of J of omega PC. So omega PC is nothing but phase crossover frequency. So you have to find out that value. How to find out that value? Then you take this polar plot. this polar plot crosses the x-axis. Okay, at what point it crosses the x-axis? 0.055. Only at this point it crosses the x-axis. Okay, so therefore the gain margin is equal to 1 divided by 0.055. So we will get 18.18 dB. The next one, this polar plot it is not crossing the unity circle. Okay, so it is not crossing the unity. So therefore your pi GC value. So pi GC is nothing but gain crossover. Phase angle at gain crossover is equal to infinity. So therefore the phase margin is nothing but 180 degree plus pi GC. So here the pi GC value is infinity. So therefore we will get the phase margin is equal to infinity. So in this way only how to do your polar plot. I think this video is useful for you. Thank you for watching this video.